Hi, so today I'm talking to James, and I'll give you a chance to introduce yourself.
Hi, so I'm James. I recently graduated from SFU from Mechatronics. I am working as a robotics designer at the moment, and I'm here to talk about that career choice and the pros and cons and all that stuff. Thanks for having me.
Yeah, of course. So, as a robotics engineer, then what would you say? Obviously, robots, but maybe if you get more specific into what parts of the robots you work on and kind of the type of projects you work on and your role in them.
Yeah, absolutely. I can't get too into the details due to NDAs, but as a robotics designer, you look at the objectives and the different criteria you're trying to hit, and then start brainstorming and formulating different ideas, concepts, and bringing those concepts into designs through maybe 3D modeling on CAD or even just hand sketches. Then you find components of different power transmission components you buy off the shelf, or you design things yourself and bring it all together into assembly and send it out to machinists, get it manufactured, and finally put the robot together. So that's pretty much the whole overview of what a robotic designer does.
Okay, cool. Then would you say you're present then throughout the whole life cycle of the robot design, or do you guys just focus on one component?
If you get lucky, the whole cycle, obviously, but as you get into a bigger company, obviously you don't get to get your hands deep into all the different parts of the robot. At the moment, I work in a bigger company, so I only work on certain parts of it. But at my previous company, I did work on the cumulative design.
Okay, cool. So then would you say small companies you get to be more involved in every step and then big companies more specialized?
Oh, definitely, yeah. Yeah, I think everyone does recommend that you start off small because that's where you get to really try out different parts of the engineering process. But as you get more experience, expertise, and you want to start specializing into different parts, then maybe joining a big company where you're focusing on that one objective becomes a bit more useful. Yeah.
Okay, cool then. So in a normal day, what does an average day look like for you then? I'm sure it varies based on what part of the life cycle of the project you're at, but
Hmm.
what would that look like?
Right. Good question. Usually I would be on my computer, uh, pretty much designing just on 3D models. And I think that that's an average day there. I mean, it varies. Sometimes I'll be doing drawings, sometimes I'll be doing sketches, and sometimes just design validation, but that's pretty much it.
What would you say then is like the proportion or the percentage of your time you spend at the computer?
Hmm. Uh, I think I'm on my computer 90% of the day.
Okay, cool.
Yeah.
So then what would a really good day look like for you then? What's a day that maybe stands out as a highlight for you that you really look back on and you really like enjoyed?
Mhm. I think the best day in terms of my engineering career is when we all come together as a systems design team, and we have electrical designers, we have mechanical designers, we got software developers, and we're all talking as a group trying to plan out what the robot needs in terms of feature functions, design criteria, objectives, and then we make this whole list of what the robot needs to accomplish. And that brainstorming session is probably the most fun you'll ever have as an engineer.
Yeah, I always imagine like a big conference table and everyone's around the table just
Yeah.
about it. What would you say then a kind of more challenging day you've experienced
Hmm.
has been?
Yeah. In my recent careers, which has only been maybe like less than a year, sometimes you'd order parts from a machinist and they would come back not to spec, so it wouldn't fit together due to like mismatched tolerances, for example. And those days are tough. Whether you manually fix it with your own machine tools in the office, or you send it back, or you have to redesign your component. Maybe it was on your side. You incorrectly designed something, or they incorrectly machined it. So those days are tough, where things don't work out.
Okay, that makes a lot of sense. I mean, never like
Hmm.
buying a Lego kit and not having the pieces fit together.
Pretty much, yeah.
So what are some pros and cons you've experienced then by pursuing this type of engineering as your career?
Good question. Pros, I love working with robots. It's my passion, and I get to work on, someone say, leading technology in terms of new technology that the human race is working on. So that's pretty exciting. In terms of cons, I would say that because you are at such a high fast-paced environment, you're kind of expected to match that pace. So you are always thinking, okay, what else can I be doing? How can I help make this faster? Or how can I push this progress forward more? So your mind's always thinking about work.
Yeah, I've heard that a lot from a lot of engineers, especially in the private industry. There's a lot of stress and pressure to hit deadlines and stuff like that. Is there any advice you would give to students who are considering choosing the career path that you've taken? Like maybe learning, because we don't really get taught a lot of coding, as far as I know, in mechanical, which mechatronic specialty often goes into. So what's some advice, maybe regarding coding, maybe regarding other stuff that you would give to students?
Good question. So yeah, I was initially interested in mechanical as an engineering degree, and I applied strictly to mechanical, but then I saw SFU's program for mechatronics. I was like, wait, what is this? You go and learning about electronics, you learn about systems design, you learn some software development, and that kind of opened my eyes. I was like, wait, this could lead into robotics, because knowing just one specific facet of engineering doesn't, well, I mean, it's very useful. And if you can focus all your energy into one style or one part of engineering, that's where you'll see the best come out in you, right? But if you also know at least a little portion of each part of engineering, then you can piece it together and help kind of lead the decision. So if you know more about the electronic design for a robot, then it'll help you on your mechanical design. Or if you know how the software team is going to code it and how the controls works, that will also impact your engineering design from the mechanical side. So even if you're not, let's say, taking electronic courses, or if you're not taking software development courses, it's always nice to learn this stuff on your own at home. So sometimes I'd be at home learning how to do web development in case I need to learn how that impacts my design, or I write Python scripts for like machine learning just to see how the machine learning team kind of operates. And then sometimes I'd be designing circuits, very low level, obviously not a professional level circuit, but I still try that out because it helps you and better informs your design process.
Yeah, that makes a lot of sense. I think that's something that a lot of students maybe overlook. It's that while you do specialize in one thing, it really is so valuable to get information about all the other specialties out there so you can work with them.
Definitely, well put.
One last question for you before I let you go. What is maybe one funny thing or one unexpected thing that you learned after you started working in industry?
That's a great question. I wouldn't say this, maybe it's not so funny, but I realized that not everyone you meet will be passionate about the job or the industry that you're in. And on the other hand, some people are very passionate, even more so than you are. And meeting those people that's important. Meeting the people that's just there for the daily grind, that's just there for money. Those are the people that you don't want to learn from, because as an engineer, you need to be passionate about what you're doing because you impact lives, whether it's through safety or if you're just designing new technology that can help push society forward. You need to have the right mindset in terms of your career. And some companies that you go to, you'll meet like people that don't really care. And in other companies, you'll meet everyone cares at that company. So that's the company you want to be at, because they're all synchronized to the right objective. They all share the same mindset and the same goals. And that's where you'll see the company has great success, because everyone is matched on the same pace.
Yeah, I really think that's something important to realize when going into engineering, because we've hit on it earlier, we're a small versus big company, and I've hit on it again for passionate versus unpassionate employees. But a lot of the time, the company makes the biggest difference between whether or not you enjoy the engineering you're doing and what you're not doing. A lot of the time, maybe if a student does a co-op and they don't like their co-op experience, it could have just been the company. And so it's important to keep in mind going forward.
No, definitely. Agreed.
Okay.
I guess one last piece of advice, I would say just find someone that's within your field that you want to get into and just try to reach out to them, see if they could become your mentor, if they have any advice or even just small tips on how to break into that field, how to develop skills that will get you in there. and just read the news of like, oh, this new company developed this technology that is within my industry, and I need to learn about that. Yeah.
Well, that's awesome. I'd really like to thank you for taking the time today to come chat and share your experiences and give some advice. A lot of people are really going to get a lot of value out of it. So thank you.
Absolutely. No worries. You're welcome. Thank you.